Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, this is lesson 14, Deriving the Quadratic Formula. Before I begin this lesson, I just wanted to point out to you, if you didn't already see it, that I have a watermark right here. Alright, I don't want a watermark. But this is the basic version, which is free, and unless I connect it to a smartboard, which I don't own, I'm at home right now, then I'm going to have this watermark in my video, unless I pay $109 to get a licensed version without the watermark. So for $109, I guess I'll just have this watermark and I'll have to work around it. So let's move on, and it says to derive the quadratic formula. So the opening exercise says, solve for x by completing the square. X squared plus 2x equals 8. Well, we have a rule. And that rule is to solve by completing the square, factor out the leading coefficient. So the first thing I want to look at is the leading coefficient. And as you can see, it is a 1, so I don't need to factor it out. Complete the square and balance the equality. Okay, so what I'm going to do is, step 1, I'm just going to put a parentheses around x squared plus 2x, and I'm going to leave a space, and I'm going to put equals 8. So I haven't changed the equation at all. I put parentheses here and I left a space here. But now, to complete a square, we take b divided by 2, and we square it. That's the rule, and that becomes your c. So you take your b term, your linear term here, divide it by 2, and square that quantity. That's why I have parentheses here, and that will be your new c. In other words, b is 2 divided by 2, and I want to square that, which equals 2 divided by 2 is 1 squared, which equals 1. So that is my c. So I'm going to put it here. I'm going to put it here. Okay? So that's that. That is the rule on, let me move that over. That is how we complete the square. That's the first step. We want to get this. So that is a perfect square now, where we have a term. The first term is x in each. And notice I took 8 plus 1, which is 9. So x times x is x squared. And the signs are both positive, so this is going to be positive. And I want this times this to equal that. Well, it's got to be 1 then. 1 times 1 is 1. And then if I FOIL, I'll get x times x is x squared. X times 1 is x. 1 times x is x. So that adds up to 2x. And then 1 times 1 is 1. Doing the distributive property. So whenever I have something times itself, that's a square. So I can rewrite this as, I can rewrite this as x plus 1 squared equals 9. So then I need to take the square root of both sides. So if I take the square root of the left and I take the square root of the right, I get x plus 1 equals plus or minus the square root of 9, which is 3. So I'm going to rewrite this. I don't want an equation to equal two different things, so I'm going to say, well, that means x plus 1 equals 3, or x plus 1 equals negative 3. And then I'm going to solve for x by subtracting 1 from both sides, and I get x equals 3 minus 1 is 2, and then over here, if I subtract 1 from both sides, I get x equals negative 4. So I'm just going to put that little word in here, or. So x equals 2, or x equals negative 4. So this equation could also have been solved by factoring, but whenever we're doing something, we're supposed to answer the question that's asked. And it told us to solve for x by completing the square, so that's what we did. So there are the two solutions to this quadratic. Okay, here's problem B. Okay, solve for p by completing the square. Now notice in this one right here, there is a leading coefficient of 7. Alright, I need to get rid of that before I do anything. So the first thing you want to do is just isolate your variables on one side. So I take this 7p squared minus 12p, and I'm going to subtract 4 from both sides. We've been doing this long enough now, I'm not going to show it. But if I do that, I'm going to end up with this positive 4 being subtracted is going to cancel over here, and subtracting 4 from 0 is going to give me negative 4 on the other side. So really, when you're moving up an addition or a positive number over to the other side of an equal sign, it's going to become negative. And if you're moving a negative number over to the other side of the equation, it's going to become positive. Okay, so now I'm going to focus on this leading coefficient. So let's factor that out. So I'm going to put 7p squared minus 12p. Okay, we factored out the p squared, but if I take 12 and divide it by 7, it's going to be 12/7 p. And then I need to leave a space and put negative 4 over here. Now remember, this is my b. So what you do is you take a half of b, a half of 12/7 is 6/7, and then you square that. So it's going to be 36 over 49. Okay, and that will reduce to nothing. It will not reduce. Okay, so there's a couple of different ways we can do this. I'm just going to put it in here this way. I'm just going to leave it plus 6/7 squared. I'm not going to put this 36 over 49 here. Okay, but over on the other side I will. Alright, so, and as well, if I factored out a 7, I'm actually factoring out 7 from the whole thing. So I need to multiply the other side by 7 as well. And I'll explain that when I get over there. So first I'm just going to put plus. And notice that this 7 is right here. It's 7 times p squared, 7 times negative 12 over 7p, and 7 times this. Well, since we're adding this, we're adding a multiple of 7 to it because of this 7 outside the parentheses. So in essence, we need to have 7 times this number here on this side. Okay? So 6 over 7 squared is 36 over 49, and 7 times 6 over 7 squared is 7 times 36 over 49. So we're just adding a multiple of 7 of these to both sides. Hopefully you see that. All right, so now in doing this, we are now going to simplify, and when I complete the square, it's going to be, this number outside doesn't change. We're going to get 1p, because p times p is p squared, and the middle term goes away, and we just end up with what's over here. But it has to be the sign of the middle term, so it's minus 6 over 7 squared, and that equals negative 4 plus, now these will cancel and become 7, so it's 36 over 7. Okay? And then from there, we want to multiply both sides by 7, or divide both sides by 7. So if I divide this by 7, and I divide this by 7, these cancel, and I get p minus 6 over 7, quantity squared, equals, and let's see what would happen here. Okay, let me show you what's happening here if we divide this by 7. If we divide 4 over 1, if you will, by 7 over 1, that's the same as multiplying by the reciprocal. Okay, so that'd be 36 plus or minus 4 over 7. All right, and this is getting a little messy here. So what can we do here? If we multiply this by to get the same denominator, if I wanted a 7 down here so we could add these, 7 times 4 is 28. And that's probably what I'd want to do. So I would get a negative, or actually it's not negative anymore. It's going to be 7. And negative 28 plus 36 is 8. So I'm going to get 8 over 7. Okay, so now we have this 7 over 1 here. Well, if I multiply by 1/7 instead of dividing by 7, that's what we're going to get there. So this is going to clean up nicely to p minus 6 over 7 squared equals 8 over 49. Now I take the square root of both sides, and I get p minus 6 over 7 equals plus or minus the square root of 8 over 49. The square root of 8 can't be simplified, so I'll just leave that. And the square root of 49 is 7. So I can rewrite it like this. So if I solve this now, I get p equals, just add 6/7 to the other side. P equals 6 over 7 plus or minus the square root of 8 over 7. Okay? And if you wanted to plug that in your calculator, you could get a decimal value, but it didn't say to, so I could just stop right here. 6/7 plus the square root of 8 over 7, or 6/7 minus the square root of 8 over 7. Okay, this next discussion, it says to solve ax squared plus bx plus c equals 0. So it's a quadratic, but we don't have numbers. We have a, we have b, and we have c. So how are we going to solve this? In other words, how are we going to get something to say x equals? And that's what they're asking us to do. So here are the steps. So the first step is you want to gather the variable terms and factor out the leading coefficient. Okay, what does that mean? Well, the variable terms have to be on one side of the equation. So that's, and it says we can do two things at once here and factor out this a. What that means is take a x squared plus bx, leave a space, equals negative c. So I subtracted c to the other side. Just like what I did on the last problem, but we don't have numbers here, I have letters. Okay, so I'm going to put a plus here, and there's a blank space for completing the square. So now I want to complete the square inside the parentheses. So my next step, I'll change colors for this. I leave the a outside, and then I have x squared plus bx. So remember, we're going to take that b, divide it by 2, and square it. Okay, so it's going to be let's see. Oh, I'm sorry, I made a mistake already. If I factored out an a from here, I have x squared. If I factor out an a from the whole thing, I have b over a, not just b. So I forgot my over a. So this is going to change as well. So what this is, my b over a is my middle term. So it's going to be b over a squared, or half of it. We have to divide that by 2. Let me rewrite this. So we have the middle term, b over a, divided by 2, which is the same as divided by 2 over 1. I'm just showing you what's going on here, and square it. Well, that is the same as saying b over a times a half, right? Multiplied by the reciprocal, and that is going to get squared. Well, when I do that, b times 1 is b, and a times 2 is 2a, and I get b over 2a quantity squared. Okay? So this is going to be plus the quantity b over 2a, quantity squared, close the parentheses, that's this parentheses, the whole thing, and that is going to equal a negative c plus the same thing. The a, the multiple of a, times this term here. Since we added a multiple of a times this, we're going to multiply a multiple of a times b over 2a quantity squared. Okay? Oops. Wanted to just draw a line there to block that out. All right. Okay, so it's looking more complicated, but we'll get there. So now what we're going to do is simplify the fraction on the right and multiply both sides by 1 over a. Okay, so we're going to simplify the fraction on the right, meaning right here. So what is b squared? Well, that is b squared. And what is 2 squared? 4. And what is a? Quantity a squared is just a squared. So that's b squared over 4a squared. So we simplified that and we basically just distributed the exponent inside the parentheses. And then we wanted to also multiply both sides by 1 over a. So if I multiply this whole thing by 1 over a, and I multiply this whole thing by, let me get this out of the way now, multiply this whole thing by 1 over a. All right, what's going to happen? Okay, so if I multiply 1 over a times a, it goes away. So the a is gone, leaving me with x squared plus b over a plus b over 2a quantity squared. Okay, so that just got rid of this here. Then 1 over a times a, gone. Multiplying this side, I'm going to get negative c over a, and then these a's are going to cancel. So the plus sign's still going to be there, and that's not a 9, it looks like one. Let me fix that. Okay, so what did I just do here? 1 over a times negative c is negative c over a, plus a times 1 over a cancels, and we are just left with this. Okay, a little confusing, but hopefully you're still with me. Okay, so now we want to factor the perfect square on the left. So that's going to be the first term. Ignore the middle term, plus this last term, b over 2a, and now the whole thing is squared. So there's our perfect square. So if I wrote this out twice, it'd be x times x gives us this, x times this 2 times would be 2 b over 2a's, and the 2's cancel, giving us b over a. And then this times itself is that quantity squared. Equals. All right, so now we have to simplify this. It's 2 fractions being added. We need a common denominator. So this has an a squared, this has a 4. So this factored is 4 times a, if you will. And this just has an a. So this on this side is already accounting for this a, so I need 4a to get 4a squared, okay? So I have to multiply, let me use different color, I need to multiply negative c over a times 4a over 4a. I'm going to show my work. So it's 4a over 4a times negative c over a plus b squared over 4a squared. So when I multiply these, I'm going to get negative 4ac over 4a squared, okay, plus b squared over 4 a squared. Now my denominators are the same, so I have negative 4ac plus b squared or b squared minus 4ac all over 4a squared. And I'm just going to bring this down. All I'm doing is bringing this down. X plus b over 2a quantity squared. All right. Now we want to take the square root of both sides. Since we have a perfect square over here, I want to take the square root of both sides. So that is going to leave me with x plus b over 2a. And that squared is going to cancel from the square root, and that is going to equal the positive or negative the square root of b squared minus 4ac over 4a squared. Okay. Now we're going to clean this up. I'm solving for x. Remember, all we're trying to do is get this x all by itself, and we are almost done. If I subtract b over 2a from both sides, that will give me x equals, okay, these cancel, plus or minus the square root of b squared minus 4ac over 4a squared all over this, or what we're doing really is subtracting, so that's going to be minus b over 2a. Okay, so this is going to lead up to x equals, I'm going to put this first, negative b over 2a plus or minus the square root of, now I'm going to change something here. I'm going to just put the numerator. I can't do anything with this numerator, but the denominator is a perfect square. So if I take the denominator square root, the square root of 4 is 2. The square root of a squared is a. Okay. And since we're adding and subtracting and the denominators are the same, I can now finish. X equals negative b plus or minus the square root of b squared minus 4ac, and then put it all under one denominator of 2a. And this, my friends, is the quadratic formula. Okay, we just derived the quadratic formula. Booyah! Okay, on to page 2, exercise 1 through 4. It says to use the quadratic formula to solve each equation. So on the prior page, we just derived the quadratic formula by solving ax squared plus bx plus c equals 0 and solving for x. So here's the quadratic formula, and now we're going to put it to use. So in this equation, we have x squared minus 2x equals 12. So here they've already told us a, the leading coefficient, is 1. B, the linear coefficient, is a negative 2. And c is a negative 12. Why is that? Because if you're going to solve a quadratic, it has to be equal to 0. So first thing I would do is subtract 12 from both sides. And when I do that, I get x squared minus 2x minus 12 equals 0. Hence, a1, b negative 2, c negative 12, which they're telling us right here. So all we're going to do is substitute these values in. So my equation is x equals negative b. b is a negative 2. Careful with your negative. It says right there, watch the negatives. A negative 2 is a positive 2. So always be careful with that. So it's 2 plus or minus the square root of b squared. I'm just going to write it for starters. Negative 2 squared minus 4 times a, and a is 1, times c, which is negative 12. So all this is, once you know the formula, is substitution. And you divide that by 2 times a. Okay? And then simplify. X equals 2 plus or minus the square root of negative 2 squared is positive 4 minus 4 times 1 is 4. 4 times a negative 12 is a negative 48. A negative times a negative is positive. Be careful with your signs. All over 2. So this is going to simplify to x equals 2 plus or minus the square root of 48 plus 4 is 52 all over 2. Okay, we always want to simplify our radical. So if I take the square root of 52, and you've been in my class or watched my videos, this is how I show how to simplify a radical. So 52 factor tree, 2 times 26. 26 is 2 times 13. 13's prime, I am done. There is a pair of 2's that can come outside, and the leftover stays in the radical. So square root of 52 is the same as 2 square root 13. In simplifying that, now I have x equals 2 plus or minus 2 square root 13 all over 2. Okay? Well, these 2's cancel, or they reduce. 2 divided by 2 is 1, plus or minus 2 divided by 2 is 1. 1 times the square root of 13 is simply the square root of 13. So the answer is x equals 1 plus or minus the square root of 13. Okay, number 2. All right, so we have 1/2 r squared minus 6r equals 2. So here's your equation. I want this to equal 0, so I have to subtract 2 from both sides. So that would be 1/2 r squared minus 6r minus 2 equals 0. So here's my a, 1/2. B, negative 6. C, negative 2. Don't forget this negative. So there we have it. Now we're just going to write this formula. And when you do these, write the formula every time, because that'll help you memorize the formula. I'm just going to use it from over here just to save time in the video. So x equals negative b, which is a negative 6. Again, don't forget that negative sign. A negative 6 is positive 6, plus or minus the square root of b squared, which is negative 6 squared, minus, I was thinking the plus or minus, we've already done that, minus 4 times a times c. Negative 2 all over 2 times a. So simplify. 6 plus or minus, I always take care of the radical first. Negative 6 squared is positive 36. Keep in mind this number here will never be negative. Most common mistake, making that a negative. Okay, minus. Well, 1/2 and 2 reduced to 1. That's a negative 2, by the way. There's a minus sign there. Let me rewrite that, because my pen, when I write, snaps to the next thing I write if I write too quickly. All right, so negative times a negative, so this is going to be positive. 1/2 of 4 is 2. 2 times 2 is 4, so that's 4. Divided by 2 times 1/2, which is just simply 1. So I don't even need my fraction bar here, because anything divided by 1 is itself. So this is cleaning up very quickly here. X equals 6 plus or minus the square root of, now I'm going to stop right there. That'd be the square root of 40. But I see a perfect square already, so why do a factor tree when you don't have to? The square root of 36 is 6. And the square root of 4 is 2, but let's just do it this way, square root of 40. All right. So 40 with a factor tree is 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. And we have a pair of 2's, and these are obviously not a pair, and they're all by themselves, so we're going to ignore, and this stays in the radical. So this is x equals 6 plus or minus 2. These two 2's are square root of 4 is 2, and the square root of 10. And that is our answer. Okay, number 3. We have 2p squared plus 8p equals 7. A is 2, b is 8, and c is negative 7. Because if we move this over here, it'd be minus 7 equals 0. I'm just not going to do that this time. So now I write x equals negative b, which is a negative 8. Negative b, b is 8, plus or minus the square root of b squared. That's 8 squared minus 4ac. All over 2a. Okay, there's my substitution into here. Now I get x equals negative 8 something happened with my pen there, plus or minus the square root of 8 squared is 64. Negative and a negative is going to give me a positive here. 4 times 2 is 8. 7 times 8 is 56. All over 4. So x equals negative 8 plus or minus the square root of 64 plus 56 is 120 divided by 4. Again, take the square root of 120, doing a factor tree, is 2 times 60, which is 2 times 30, which is 2 times 15. I'm just going to go all the way down. I know this isn't going to work, but I'm just showing you. And the square root, we want pairs. A pair of 2's becomes 2 outside. So x equals negative 8 plus or minus my pair of 2's, that becomes 1 outside. And these 3 here are not pairs, so you go back to that number there and leave it in the radical, all over 4. This will simplify to negative 8 divided by 4 is negative 2. Actually, I can't go down that far because 2 is less than 4, so let me change that. I can take a factor of 2 out of all of them. So if I take a factor of 2 out, I get negative 4, plus or minus 2 divided by 2 is 1, so that's the square root of 15, all over 4 divided by 2, which is 2. Okay, so it's negative 4 plus or minus the square root of 15 over 2. Okay, one mistake I wanted to fix here real quickly. Eraser. This is not 15. I didn't go far enough up. 2 times 3 is 6 times 5 is 30. So this should be radical 30. My apologies there. So the answer is negative 4 plus or minus the square root of 30 over 2. That is the final answer. Okay, number 4, 2y squared plus 3y minus 5 equals 4. Again, we need to get this to equal 0, so I need to subtract 4 from both sides. And when I do that, I get 2y squared plus 3y minus 9 equals 0. So that's where the a is 2 comes from, b is 3, and c is negative 9. So now I have x equals negative b, which is 3, plus or minus the square root of b squared minus 4 times a times c all over 2a. So x equals negative 3 plus or minus the square root of 3 squared is 9. Negative times a negative is going to make this positive. 4 times 2 is 8, times 7 is 72, all over 2 times 2, which is 4. Okay, simplify the radical. (72 plus 9 is 81). That is a perfect square. This one's going to be easy. Negative 3 plus or minus 9 over 4. So x is going to equal negative 3 plus 9 is 6 over 4. And that is going to reduce to 3 halves. And then x equals negative 3 minus 9 is negative 12 over 4. And that's going to reduce to negative 3. So we have positive 3 halves and negative 3. And I shouldn't say and, I should say or. X can't be two different things. So it's either 3 halves or negative 3. Okay, here's page 3, exercise 5. It says solve these quadratic equations using a different method for each. Solve by factoring, solve by completing the square, solve by using the quadratic formula. Before starting, indicate which method you will use for each. Okay, so if I look at these, some may be factorable, some may not. And with a little practice, you will see that this second one is not, because there are no factors of negative 5 that will add up to 3. So I'm not going to factor this one by factoring, obviously. It's got to be something else. So let's say factoring this one. Let's factor this one. Okay, and I'm going to do my method of factoring where I take a and multiply it by c, and I get x squared plus 5x minus 6 equals 0. I want factors of c that will add up to b. So it's 1 times negative 6, or 2 times negative 3, or negative 1 times a positive 6, or a negative 2 times a positive 3. And I want it to add up to 5. So this equals negative 5 when I add them. And this equals negative 1 when I add them. This one equals 5, and this one equals 1. So I want this one. So my factors are going to be x minus 1 and x plus 6. Okay, but I multiplied by 2, so now I need to divide my terms by 2. And if it doesn't divide, then it becomes your leading coefficient. So let me move this table out of the way. So the 2 will go out in front, so I have 2x minus 1. And this one does reduce. 6 divided by 2 is 3. So there are the factors. So x will equal, and my answers are the opposite sign of what's up here, which makes this way of doing it easier. So I have a minus a half here, so it's going to be x equals 1/2, or x equals negative 3. Okay, so that is this one. All right, number 2. What method are we going to use? How about the quadratic formula? No. I'd rather do completing the square on this one. I don't like completing the square when I have a fraction out in front. I don't like factoring out that fraction. It's just a personal thing, so I'm going to solve this one by complete square. I'm not going to write it all out, but alright, so we're going to complete the square on this. So you should be familiar, if you practice this enough, plus 3x equals 5. So get the constant over on the other side. And while I'm doing that, I should leave a space. And then I take half of 3. So it's 3 divided by 2, and I want to square that, which equals 9/4. So that's going to be plus 9 over 4. What you do to one side, you must do to the other. So this is now a perfect square. So it's going to be x plus 9 over 4 quantity squared equals, and keep in mind that if this has to have a denominator of 4 and this has a denominator of 4, it's 20 over 4. 20 divided by 4 is 5, plus 9 over 4, yes. Alright, so we have x plus 9 over 4. It snapped. Oh, snap. And squared equals 29 over 4. Okay. Okay, just realized something real quickly. This is not 9/4. Okay, remember when we do this, this number that's inside is going to be what goes here. Okay, and I caught that because I always double check and I say to myself, x times x is x squared, x times 3 halves plus x times 3 halves is x plus 6 halves, which is 3, and I had 9/4 and 18, that'd be 18/4 does not equal 3, and that's how I caught that. Okay, so anyhow, there's that, and then it is 9/4 here, 9/4 here, and getting 29 over 4. Now we finally take the square root of both sides, like so, and we will get x plus 3 over 2 equals the square root of 29 over 2. And then subtract 3 halves from both sides, and we get x equals the square root of 29 minus 3 over 2. And I forgot my plus or minus here. So, or x equals the square root of, or the negative square root of 29 minus 3 over 2. So either one will work. And you could have it the other way around. You could have negative 3 plus the square root of 29, or negative 3 minus the square root of 29 over 2, which is more appropriate, having the radical after the constant. But anyhow, either one, when you simplify it or put it in a calculator, will come out with the same decimal approximation. Okay, and finally the last one. We've done factoring. We've done completing the square, so I have to do this one by the quadratic formula. QUAD. Quadratic formula. Alright, so that is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you've memorized that. And then I want to list this. So remember, we want to get the constant over on the other side first, and so on. So let me just move this formula over to here. We'll just use the whole paper here. Alright, so the first thing we do is take, and we have a equals a half. It's already equal to 0, so we're okay. B equals negative 1, and C equals negative 4. Alright, so x equals negative b, which is a negative negative 1, or 1, plus or minus the square root of b squared, which is negative 1 squared, minus 4 times a times c, all over 2 times a. Okay, this is going to come out nicely. So it's 1 plus or minus the square root. Negative 1 squared is 1. A negative and a negative will give me a positive. 4 times a half is 2 times 4 is 8. All over 2 times 1/2, which is 1. So we don't need to do anything over 1, because anything divided by 1 is itself. So look how nice this is. X equals 1 plus or minus the square root of 9. So x equals 1 plus 3. Or x equals 1 minus 3. So x equals 4, or x equals negative 2. And there you have it. Okay, page 4 brings us to the end of the lesson. That is the end of lesson 14. Review the lesson summary and go do your problem set.